Welcome to the video, Specifying Document Attributes, Data Types. In this video, we're going to look at documents. We're going to make sure we understand fully what a document is. We're going to look at all the data types that Elasticsearch has. It's a big list, so get ready, get a cup of coffee. Then we're going to look at mapping files and templates. Alright, let's go through this as if you're familiar with a programming language, but maybe not necessarily Elasticsearch data types. And I'll give some examples on a couple of them that we'll talk about that are important. The first set of data types we're going to look at are the string ones. So text and keyword. So if you know, Elasticsearch is built on Lucene, which is the open source standard for full text indexing within Java. So a text data type or a value type text will be fully indexed using the full text search engine Lucene. And so you can do pretty complicated searches across that data as time goes on. For example, if you had a string, the quick brown fox did something or other, that would be broken up into smaller chunks to search things like fox or quick. A keyword, though, is different. So a keyword is used when you only care about the exact value. For instance, you have a color attribute, but you have a finite list of colors where you have red, green, yellow, blue, purple. You'll never have anything but yellow, green, blue, purple. And even if you did have something like blue, green, you wouldn't want that indexed as blue and as green. You'd want it indexed as blue, green. So that's when you would use a keyword, when you only care about the actual value that comes into the field. Then you talk about the other normal number or numeric types, long, integer, short, byte, double, float, half float, scaled float. Look at the exact documentation to cover when you would use each of those within your data types. Normally you'll be using long for really big numbers, or integer for your standard integer range, shorts for small values. Floats are going to be used when you have decimals, etc. So look at the exact documentation. Date is exactly what it sounds like. It's a date and timestamp. You can use a bunch of different formats when you inject data into Elasticsearch to map it to an actual date. You can use string formatted date like you would see, a UTC formatted date. You can use a epoch since 1970, in seconds or milliseconds. Next type is a Boolean type, true, false. A binary type I would use for storage more than anything else. It's not going to be indexed or anything. So you can put some binary data in there. Then you have some other range values, which you can get more information from the documentation if you dig into that. Then there are other types. So you can have an array type, which is basically a list of values. An object or a nested object can be held in an attribute. These are useful when you have some local parent-child documents. You can't do actual foreign key joined relationships within Elasticsearch like you can most relational databases. But here you could use some different object type. At least relate a little bit of data together if you have a parent-child kind of relationship. Since Elasticsearch is document-oriented, and it's not a normalized relational database, you're going to have a lot of duplicate data within your indices, and that's okay. So you don't ever want to try to normalize things because it just doesn't work. One of my favorite parts of Elasticsearch, two data types outside your normal ranges that I think are fascinating. You can have a geopoint, which is a point on a map, represented by an X and a Y or a longitude, latitude within a numeric range. Then there's a geoshape as well. So if you think about a point as one dot on a map, you can have different geoshapes. You can have circles, you can have lines, you can have polygons. You can have a lot of different types there to represent whatever you're looking at. So if you're doing some sort of mapping or some references to find the closest gas station, you can use a geopoint. Or if you want to do an application where you're building the logic like when I leave my house and you want to basically do a geofence, you could use a geoshape polygon to say what's around your house. So remember the geodata types when you look into stuff on a map. The next one that my favorite is the IPv4, IPv6 IP data type. I do a lot of network monitoring, a lot of network security, and so I use IPs all the time. The reason we have an IP data type now is so we can do, CIDR range searches or internal private IP searches, public IP range searches. You can look for IP ranges within your network, within somebody else's network. So that's a good data type. Completion is used when you're building like a search engine where you want to complete someone's typing. Token count takes a string and counts how many tokens in it. Then you can look at the other ones in the documentation. They get a little complicated, and for a 10-minute video, it's not worth jumping into. But they're much less used, but could be useful in your application. So let me show you an example. So this is not a very hands-on video forgive me, but we're talking about data types. So if you're familiar with, integers and strings and text fields and all that kind of stuff, then so our example on the right is a document representing a run. So this run is named the Thanksgiving Turkey Trot. And if we look on the left, we can see we have a mapping document. We have the type of race. Then we have a list of properties. And if you look in that properties, you have name, value, pairs. We have name. So if we look down, we'll see name is text, which means Thanksgiving Turkey Trot will be fully indexed. Then we run into the type of run versus walk versus bike versus crawl, I guess. And that's a keyword. So when we start doing graphs and we start doing counting on tokens, we'll count run as a unique token and we'll count them all the other things with run as an example. We have a float for the advertised distance. So this is a 10K run. We have a duration of how long my run took. It took 3,660 seconds, which should be an hour and 1 minute. I started my run on November 18th, 2018. So the start time, you'll see, is mapped as a date. Now you'll see the format. This is where you can tell Elasticsearch what your data is going to look like before you give it to it. So you can say, look at the strict date optional time, which means if you look at the value we have for start date time, we have the date, 2018, 11/18. That is the strict date. Then the T signifies after the T is a time, so we have 1,300 hours. And that is the optional timestamp. So if I didn't have that timestamp, it's okay. I think Elasticsearch would default it to midnight. Or we can use the value of epoch millis, which is milliseconds since the epoch, which is 1970, Jan 1, I believe, Jan, something like that. All right, then we're going to get into the start location. So it's defined as a geopoint. And if you're not familiar with geohashes, I recommend looking up. It's a great way to store points on a map. You could alternatively do a latitude, longitude, but here I did DQ8SWM576GG9. I'll look it up on a map for bonus points. So you can find where that location is as I started my turkey trot. And then my shape of Maine, because I couldn't figure out a run. So hey, I just picked a list of geocoordinates for you to see. This is a shape of Maine. It is a type polygon, and it is mapped to a geoshape. And you can see here it's a list of coordinates. So each of those coordinates is a point on the map. They could also be represented as a geohash or latitude, longitude like they are right here. And if you drew this out on a map, it would be the shape and the location of the Maine borders. Maine is in the state within the United States of America. So that's a quick run through of mapping and data types and an example of their values. So we will get more used to these as we go on. Now, mapping is applied to an index. So let's say we created an index called races or an index called activities or exercises or something like that. Before we inserted data, we would apply this mapping in a JSON file to that index. And then when we insert these values, Elasticsearch will know how to deal with it. If we didn't give it a mapping, then it would probably treat the name and the type both as text fields. It would probably treat the duration seconds as an integer properly. It would probably figure out most of them. But start location, it would probably treat as a string and not a geohash, which means if it's not stored as a geohash or a geopoint, that I can't do geographic-based searches. I can't draw my map, and maps are super fun to draw. So it's really important to make sure your data is set up properly ahead of time. So in this case, we created an index and applied the mapping. Well, what happens when indexes are created automatically? So we talked previously about the logging use case where I'm going to log records from all of my Linux servers, and they're all going to go to my Elasticsearch in a time-based index. So today is, I'm making up a date because it's not actually today, let's say December 6th, 2018. And I'm inserting my records into December 6th, 2018, and there you go, it rolled over to December 7th, 2018. I'm going to be now inserting my data into a new index. Well, you don't want to be sitting there every night applying a new mapping. So, well, Elasticsearch has a concept called a template. You can give a template to Elasticsearch that says, set up a mapping based on the name of an index when the index gets created. We'll look into that in the next video. So, in the next video, we're going to be talking about document types. So we've talked about cars already. We just talked about exercises or runs or races. But we're going to get more into document types. So stay tuned.